Good morning, friends. In the last period, we have discussed about the scalar triple product. In the today's lecture, we have to also discuss a second triple product, and that product is called as what? Vector triple product. Basically, we have to study about dot product and cross product. Then scalar triple product is also called as a box product. And now today we are going to discuss about the vector triple product. For vector triple product, we have to consider A bar cross B bar cross C bar. This is called as a B bar cross C bar are the vectors, and this can be multiplied by another vector, that is say A bar, that is a cross product. So it is a vector triple product of a vector. 3 vector is a vector quantity, and after that we have to consider, let us consider A bar, B bar and C bar are the 3 vector. Let us consider three vectors A bar, B bar, C bar. So A bar is equals to Ax into I cap, Ay into J cap, Az into K cap. B bar is equals to Bx into I cap plus By into J cap plus Bz into K cap. And third vector C bar is equals to Cx I cap, Cy J cap, Cz K cap. This is the 3 vectors we have to consider, and for 3 vectors we have to, then we know that B bar cross C bar is equals to, what is B bar cross C bar? We have to study it in the vector product, that is cross product. B cross C can be expressed in the form of determinant, that is I, J, and what we have to say that K, and this can be expressed as, that is Bx, By, Bz, Bk component, Ck component, Cx, Cy, Cz. This is the 2 component we have to consider here, and from this what we have to say that is equals to I cap into bracket, multiply this one, By, Cz minus Bz, Cy minus J cap into bracket, Bxcz minus Bzcx, and third term is what we have, the plus K bar into bracket, multiply this one, Bxcy minus Bycx. The determinant can be, we have to, how to can be multiplied, that is what we have to say that first column and first row, what we have to forget it, multiply this minus this one, then this minus this one, then this one minus this one. This is what we have to say that component of I, J and K. Now this is B bar cross C bar, and this is equals to what we have to say that is B bar cross C bar is called as a V bar. B bar cross C bar is called as a V bar. Therefore V bar is equals to Vx into I cap plus Vy into J cap plus Vz into K cap. So V bar is equals to what we have to say that Vx into I cap plus Vy into J cap plus Vz into K cap. Say. Now, then what we have to say that? Then A bar cross B bar cross C bar A bar cross B bar cross C bar is equal to, we have to say that this can be expressed as what we have to say that A bar cross B bar, because B cross C is nothing but what we have to say. We have to substitute for B cross C, that is equal to say P, and this can be written as, how it can be expressed, that is again vector product of two vector can be expressed in the form of determinant, that is I, J and K. Here A K component, AX, AY, AZ, V K component, VX, VY, VZ. Solve this determinant. What we have to get that? While solving determinant, this can be expressed as, that is equals to I cap into bracket. What we have to get? That is first column, first to remove it, multiply this one, AY VZ minus AZ VY. Then second term is say minus J into brackets, remove this one, that is AX VZ minus AZ VY. Third term is plus K cap into bracket. Third column we have, that is AX into VY minus AY into PX. This is the component of A and V. Now we have to consider here what are the different components. It's, that is X component. Therefore, what you have to say that it's X component. X component equal to. Now what are the X component we have? First one is what? I cap into bracket. X component is what we have? I, and I into bracket, that is what we have to say that. First of all, this is what? AY as it is. What is the value of VZ? This is Z component of V, VZ. This is the Z component of V, and Z component of V is what? B.SC.F.Y minus B.Y.C.X. That is Z component, VZ component का है, क्या है? That is what we have. That is B bar cross C bar is nothing but this is Vx, this is Vx, this is Vy, and this is what we have. This is Vx, this is say Vy, and this is what we have, Vz. Write the Z component we have, that is Bx Cy minus By Cx. This is the Z component. Then minus sign is there, and then another is what we have, that is Az is as it is. Then in the bracket, Vy component. What are the Vy component? Bx Cz minus Bz Cx. Then this is the terms, what we have to say that 4 terms, that is we have to consider here. Now basically we have to take the component of say I, so multiply it, what we have to get that, the 3 terms, it becomes what we have, X component of this one is equal to, that is equals to AY Bx Cy minus AY By Cx. First term and second term we have to write here. Ay bx cy, ay bx cy minus ay by cx. Second term, that is what we have to say, that write the first of all plus term and then we have minus term. This is minus minus plus, plus what you have to write, that plus az bz cx minus az bx cz. Now rearrange the equations. Here we have bx, here we have also bx, in this term cx, in this term cx. Now we have to adding some terms and subtracting some terms. What you have to get that? First of all, we have to add AYCY. First term is that AYCY into BX. Second term, we have to write that AYCY into BX, AZCZ into BX. This sign is what AZ, dy component is what we have to say, that that is minus, it gets plus, plus, so J component. This can be written as AYCY dx. This is the second term. Second term we have to write that दोन्ही ठिकाणी मायनस साइन असल्यामुळे तर काय होईल, प्लस येईल आणि प्लस झाल्यामुळे तर काय होणार आहे, dx minus and here we have plus, so write this term plus az cz dx. This is first one, this is second one, and then we have a minus sign is there. One term what we have to say, that ay by cx minus az bz cx. Now adding one term and subtracting one term, that is what we have to add. Adding ax cx dx, subtracting ax bx cx. Now what are the common factor here? This is bx dx, so we have to write in the bracket, that is ay cy ax cx plus ay cy plus az CZ ब्रॅकेटच्या बाहेर BX minus sign into bracket first of all AX BX plus AY BY plus AZ BZ into CX and finally it can be written as that is X component is equals to that is A bar that is equal to, this is what, first of all this is what, A bar dot C bar A bar dot C bar into what we have to say that Px, and what we have ith component into say I cap into I cap minus into I cap minus second is what, A bar dot B bar into Cx into say I cap, and finally similarly result can be derived for other component. So it can be written as A bar dot cross B bar cross C bar is equals to A bar is equals to, we have to say that A bar dot C bar dot C bar into B bar minus A bar minus A bar dot B bar into C bar, hence proof. This is the property we have to for the vector triple product of the two vectors. See here, that is A bar cross B bar cross C bar is the three vectors, and A can be expressed in this way, B can be expressed in this way, C can be expressed, and we know that vector product of two vector B cross C is can be expressed in the form determinant I J K Bx By Bz Cx Y Cz. Solve the determinant. This gets this term. Substitute B cross C is equals to say V. So V bar is equals to X into I cap plus Vy into Z cap plus Vz into K cap. Now A bar cross B bar cross C bar is equals to A bar cross say V bar. Again we have to write in the determinant I J K, A K component X A Y Z, V K component Vx Vy Vz. Solve the determinant. I into bracket multiplication of this one, J into bracket multiplication of this one minus this one, K into bracket multiplication of Ax By minus Ay Bx. Substitute the value of component of Vx, component of Vy, component of Vz. X component we have to consider, that is I into bracket. X component we have. What is the X component? See here. This is the X component we have. And for this X component, I cap into bracket, Ay is as it is, Z component of V, this one we have to substitute here. Then Az as it is, and Y component of V, this can be written this here. That is, X component is a Az as it is, but Y component is a negative. So we have to write here a positive. This gets what? Positive. And then we have to write that multiplication of this one and multiplication of this one minus sign is there. There again we have a third term is what we have to say that Az, Bx, Cz, this is a positive, and this one is what? A negative. and then one term can be added here because missing term, for sake of simplicity, we have to add one and subtract one, like that. Ax, cx, dx we have to add here, and ay, ax, bx, cx subtract here. From the first three term, we have to take the bx common. For second three term, cx common, b is common, means what? A bar dot c bar into b bar into I component. C is common, so a dot b into bx, cx by we have to take the x component. Similarly, we have to take the y component. Similarly, we have to take the z component. Similar result we have to obtain. Only change is that x के जगह आएगा y के जगह आएगा z. I component, j component, k component. And final result we have to obtain for the vector triple product. A bar cross b bar cross c bar is equals to a dot c into b minus a dot b into c, ac into b, bab into c. This is the property. Multiple choice question may be asked on that. A bar cross b bar cross c bar is equals to what? A bar dot c bar into b bar minus a bar dot b bar into c bar. First के combination में b common आता है, second के combination में c. b and c are the common. Remember, and this is the result we have to get. b and c are the common. b common म्हणजे आतमध्ये रहा a dot c. c common म्हणजे आतमध्ये रहा a dot b. Means we have a dot c into b minus a dot b into c. This is the vector triple product of the three vectors. Similar result we have to obtain, and it shows that it is in general we have to say that this is a general form of the vector triple product, which shows that in general a bar cross b bar in general we have to say that a bar cross b bar cross c bar, a bar cross b bar cross c bar is not equal to a bar cross b bar cross c bar. ऐसा equal नहीं है, because we have to say that change the direction. Hence, vector multiplication is not associative. Vector multiplication is not associative. It do not obey the associative. Vector multiplication is not associative. That is, value of vector triple product is extremely different if the order of factor is interchange. If the order of factor is interchange, it is extremely different. If the order of factor is interchange, here, see here, a cross b cross c is not equal to a cross b cross c. Vector multiplication is not associative. Right? This is the vector triple product of the three vectors, and in this way this article is finished here. Thank you. Write down all the things, and we have to take the another different types of product, that is gradient, then dot product and cross product, that is we have to discuss here. After that, divergence, gradient and curl we have to discuss in the next lecture. Thank you.